All right, welcome viewers once again to Teeta Labs. Just in case you're joining us for the first time, you know the buttons to hit. And just in case you choose not to subscribe, it's still okay. All right, what we care about is for you to learn as much as you can from this channel. Okay, now whatever we put out here is quality, and I believe that you will learn a lot. You will learn a lot. Okay, now one thing I want you to do for me is when you watch this video and it is useful to you and helpful to you, please kindly share with your friends. All right, share it with them. You know, when you subscribe and do all that, it just encourages us to do more of this amazing work. Okay, now have you heard the word programming before and you get scared? Programming in electronics and you get scared? I want you to know that you are in the right place. Okay, after watching this video, okay, you will not be scared of the word programming anymore. All right, now I'm going to do this video in chunks, these programming videos in chunks. All right, I'll do them in different chunks so the video will not be too long, and then I will not be giving you too much information that you probably might not be able to digest and as quick as possible. So just follow the series. This is the first one. I'm going to do quite a number of them. Please try and follow them and become a very good programmer. All right, now there are different chips you can program. There are different development boards out there for you to do different programming in electronics. Okay, but now let me just quickly say this. Okay, when you hear the word programming in electronics, okay, don't let it scare you. All it is talking about is finding a way to give a chip. All right, when I say a chip, I mean a microcontroller or an IC, integrated circuit. All right, if that is easier for you to understand. Now, finding a way to give a chip instructions of what to do at different times. That's just what programming is. All right, now the boards I'll be using to do this is the Arduino Uno board, and then I'll also use an Arduino Nano board to show you some things in programming. All right, now follow these videos through, okay, because you're going to learn a lot and you will be very thankful that you were a part of this. All right, so please, if you're not very busy, sit back, relax, and join me. Let's do this together, shall we? All right, welcome back once again. This video, like I said, I'm going to be doing it in chunks, and for this particular one, I just want to give you a general overview of your Arduino board. All right, now the first thing you need to know is this. Every time you want to program something, all right, like I said, you just want to find a way to tell that chip what to do at different points in time. That's just basically what programming is. All right, now this is the Arduino Uno board, and this is the Arduino Nano board. It's written on it. This is the Nano and this is the Uno. The major difference is this. Two of them can do the same thing. Okay, the major difference is this one has another different package. Now take note, it is the Atmega chip that is used on Arduino boards. Okay, Atmega chip. For this one we have the Atmega 328, and for this one we have another Atmega chip, which is surface mount, obviously. All right, now the major difference between this chip and this chip is that this one has way more pins. Okay, now it has more analog inputs. Okay, we'll get to all that. Now for this one, I'm sure you can see it's labeled analog in A0 to A5, but for this one you find out that our A is plentier than this. This one is A0 to A7. all right, A0 up to A7. Okay, you see that this one has more pins. All right, now apart from that, like I said, they'll do the same thing. Okay, so let me quickly just explain that. That's about the chips. And also, if you want to count the pins, all right, for every chip, this is how you start counting. You look for the dots here, or you look for the U letter. It looks like a letter U, and start counting that way. Okay, so this is 1, 2, 3 down to this particular one. And for this one, you start from this pin and count this way. All right, now that's it about the main chip used on this board. Then there are other terminals. Those terminals are basically connected to the pins of this chip, but it's for you to easily access the pins and do what you need to do as quick as possible. these are the pins for these ones. They are connected to this chip. All right. Now, for you to power this chip, it can be powered from a 5-volt source, which can be taken from the USB terminal here. All right. Then for this one too, of course, 5-volt source, which can be taken from the USB terminal here. Or you can power it with a 12-volt source, which can be connected here. Once you connect that here, it's powered on. Okay. Now, what is this? This is just basically a regulator. All right. Now, when you connect any power source to this guy makes sure that 5 volts is supplied to this board. The same way, if you look under this one, you'll find out that there is a regulator here too. Okay. There's a regulator here. That's this one with this one. So when I connect at my V in, this is V in, okay? So if I connect 12 volt, V in and ground, 12 volt positive, 12 volt negative, it powers on, but this regulator makes sure that this whole board works with 5 volts. Now, if you connect any voltage above 5 volts to your chips, you're going to damage the chips, all right? So they work with 5 volts, and that's basically what this regulators does. It helps to keep whatever voltage you're connecting to this V in and this ground, or to this place. Whatever voltage you're connecting to them, it makes sure that it keeps it at 5 volts to power the whole board. All right. And like I said, all of these pins are the pins connected to the chip. All of these terminals are the pins connected to this chip. All right. Now, this is your crystal. For every chip, you make use of a crystal to help set the clock speed. Okay. Now, just have that back of your mind, clock speed. I'm going to explain that in detail in the next part. But for now, just know that this should be connected to, your chip to set a clock speed. For this one too, this I believe is the clock. All right. Now it's a crystal basically, and this one is written 16.00. I don't know if you can see that. It's written 16.00. All right. Now it's written 16.00. It means that it is a 16 megahertz clock. All right. Now this is the reset button. Okay. So if you want to reset the whole chip, you just press this. The whole chip resets. The same way we have this as a reset button. Okay. Now these are connected to different pins on these chips. All right. In the next video, I'll explain all of that. For this, I just want you, whenever you pick up an Arduino board, you are able to tell what different parts are doing. Now, another thing I need to quickly mention before I round off is each time you want to instruct these guys, like I said, you want to instruct them with your codes on what to do at different times. Each time you want to instruct them, you need to do that through a computer or a device. Okay. Now I'm also going to teach you how to program your Arduino boards, okay, using your phone. Yes, you can do that with your Android phone. That is what do they call this now? That is OTG enabled. Okay, if you need to understand how OTG works, go back to my videos. I've done a video on how OTG works. All right. Now there are different apps you could use on your Android phone through an OTG cable to program your Arduino board. That's another very interesting thing about Arduino programming. All right. And then in the next video, I'm also going to tell you about the what do they call it now? Now I'm going to tell you about the Android app you can use for programming this. But of course, like I said, you can program with your phone and you can also program with your laptop. All right. Now, for you to send codes into this guy, it needs to be through maybe your mobile device or through your laptop. All right. And now your laptop connects to this guy through USB, and USB simply means universal serial bus. Okay. It works with serial bus. Meanwhile, this guy communicates with anything that wants to program it through what we call the UART. UART. Okay. UART simply means universal asynchronous. asynchronous receiver stroke transmitter. Okay, so universal asynchronous receiver stroke transmitter. Okay, that's the way it expects to communicate with anything you want to use to instruct it, anything you want to use to program it. All right, now you need something that can convert from your USB, that's universal serial bus, to what UART in order to instruct these chips. All right, and what you have on this board that does that is this. For this one, it is called a CH340 chip. Okay, this chip helps to convert from USB to UART so that you can communicate effectively, okay, between your laptop and this guy, or between your mobile phone and these guys. All right, now that's what this chip does. All right, this is your CH340 chip. That's what this guy does. All right, it helps to convert your USB from your laptop to UART, which this guy uses to communicate with outside devices. The same way, this guy too also needs that, and that's what this chip is. Okay, this chip here is Mega 16U2. Mega 16U2. This is the chip used here to convert, the communication protocol of your USB to UART, okay, to communicate with this. So for this particular Arduino Uno board, Mega 16U2 was used here to convert USB to what? UART. All right, now for this one, like I said, CH340 was used to convert from this USB to UART. All right, now I think that's just about all we need to talk about the overview of this. This is an LED. This LED just simply indicates that there is power in this board. Okay, so once this LED is on, you'll see a light here comes on. Okay, now the same way, this one too, this POW tells us that there's power on this board. Once I connect power to this will light up. All right, now what else? Okay, good. The last thing I will talk about, these pins here, ICSP header. If you check closely, you see it's written ICSP. Okay, ICSP simply mean in circuit serial programming. Okay, what that simply means is that you don't need to take this chip out of the circuit to program it. You can, from these pins, just connect different wires to program this chip. Okay, that is, if you're not using this one, you can program it from another different programmer to still talk to the chip on what to do. The same thing, we have the same ICSP headers on these ones. All that I will explain in details for the next part of this video. But for now, I just want you, like I said, whenever you pick up this board, you can tell what different things are. And okay, look at this LED. This LED is RX and TX. Okay, you see that it makes sense now. RX simply means receiver, and TX means what? Transmitter, which is receiver transmitter. So wherever you just see a receiver and transmitter on any chip, know that most likely it is a UART chip. All right, now, so whenever you're programming these ones blink periodically to tell you that there's communication between this and what you are using to program it. All right, now that's just about all. And all these pins you're seeing are the pins connected to different terminals on this chip. Okay, like I said earlier. All right, so please, if you have questions, make sure you ask me. I'll be happy to give you answers. And if this video was useful to you, please kindly do what you need to do to encourage us. Thank you so very much. and see you some other time.